with this. Rules for logs. Again, you have learned this before, I promise, but I'll pretend you haven't, okay? This is how we either condense logs or expand logs, and then we're going to see a couple cases where we can solve using logs. We'll get a lot more into like the solving stuff in section 4.4 at the end of this week. Okay, so there are 3 rules that we are going to use for pretty much every problem in this section. These are the rules written as you see them in your textbook and the names of the rules. So we've got product rule, quotient rule, and power rule. You're going to notice some similarities between these and exponent rules that we have. I'm going to give you an example on the right side when you put these in your notebook of an example with some numbers, so you can kind of see what it would look like with some values plugged into each of these. And then we're just going to do a ton of practice using these 3 properties today. Okay. So first one is called the product rule. It is allowing us to take 2 logs that are added together and condense them. Okay. And what the rule says is if I have 2 logs that are added together, M and N, whatever those are, and they have the same base A, that I can condense them. The log base stays the same, just like when we have our exponent rules, and we combine 2 exponents with the same base, the exponent base always stays the same, and we change the addition to multiplication when we condense, okay? Or vice versa, if we have multiplication and we want to separate into 2 logs, we can separate it and make it look like addition of 2 separate logs. So an example of what this would look like with some numbers plugged in is, let's say I have, what's that little eraser showing up there? That's annoying. I don't know if it's going to do that all day. Oh well. All right, log base 3 of 5 plus log base 3 of 4. Okay, so if I want to add 2 logs together, as long as they have the same base, which both of these do, they're both a log base 3, I would keep my log base the same, so it's still going to be a log base 3. And then we multiply the numbers on the inside together. So 5 times 4 gives me 20. That's how we use that property. Okay, so addition and multiplication go together, they're buddies. That's the same thing with our exponent rules, if you remember. If you're multiplying exponents with the same base, you add the exponents. Okay, so we're going to see that we've got the same sort of operations that are friends with each other. All right, the next one is the quotient rule. The quotient rule says if I have 2 logs that are subtracted, I can condense them by changing it into division, a quotient. So here's what this guy would look like. I could say log base 2 of 12 minus log base 2 of 4. Okay, so I'm subtracting logs. They have the same base. They're both a log base 2. Quotient rule says, again, base stays the same, still a log base 2. But then we divide, and order matters when we divide. So whatever's in the first log is going to be in your numerator. Whatever's in the second log is going to be in your denominator. So 12 divided by 4 here would give me 3. Okay. Last one is the power rule. The power rule says if you have a log with an exponent inside it, you can take that exponent and move it down in front of the log. This property is going to be really important when we're solving for exponents. If I have a log and I have an exponent, we can move that exponent down. It changes to multiplication. It's no longer in the exponent, and that's what allows me to solve for an exponent. So we use this guy a lot. So an example, I could say I have log base 3 of 5 squared. That is the same as 2 times the log base 3 of 5. So that exponent is just coming down in front. Or you could use it the other way. If you have something down in front, you can move it up into the exponent. They're equivalent statements. Okay? So those are our 3 rules for logs, 3 properties. Any questions on those so far? Do these look familiar? Maybe kind of, sort of. All right. So, make that a little bigger. Let's start with some of these. We'll do a couple together and you can try a couple on your own. So we're using our properties to condense logs. So when we say condense, we have multiple logs and we're trying to condense to as few logs as possible, ideally down to a single log if we can. Okay, so if we are condensing, there's 3 things you're going to look for, and it's kind of like an order of operations. The first thing we want to do is if we have any numbers in front, we're going to move them up into the exponent. Okay, so that's our power rule. Then Anything that's addition, we're going to change into multiplication when we condense the logs. And anything that's subtraction, we're going to change into division when we condense the logs. Okay, and that's our product and our quotient rule. So these are the three kind of steps that we're working through. So if I'm looking at that first one on the top left, I have log of 3x minus log of 4y. There's not a log base there, but do you remember what number we could put down in the base? 10, okay, if we want to. All right, do I have any numbers in front of the log that I can move up into the exponent? No, so we skip that step. Do I have any addition? No. Do I have any subtraction? Yes. So subtraction, if I want to condense the logs, changes to division. So 3x over 4y, it's still a log, common log, or you can say log base 10 there if you want to. And then 3x over 4y doesn't simplify. That's our final answer. Okay, so we're just merging everything together. All right, let's look at the next one. Do I have any numbers that I can move up into the exponent? Yes. What can I move into the exponent? 2. Yep. So I have 2 times a log, which means I can move it up into the power. So we could write 5 squared, but we also know what 5 squared is. What's 5 squared? So I can just change that to a 25. Plus log base 2 of 9 minus log base 2 of 75. Okay. Anything that is addition is going to change into multiplication. Anything that's subtraction is going to change into division. So here's an easy way to know where you're going to put things. You can actually do all this at once. If it's addition, if it's positive, it's going to be in a numerator. And if it's subtraction, it's going to be in the denominator. Okay, so if I want to do this all at once, it's still all log base 2. If I had different log bases, by the way, I couldn't do anything. I would just stop. 25 and 9 are both positive terms, so they're going to go in the numerator, and they're multiplied by each other. Okay, that's where we see that multiplication at. 75 is subtracted, so we divide, put it in the denominator. If I had something else that was divided, I would also put that in the numerator, and it'd be multiplied by the 75. Then we can simplify that a little bit. 25 times 9 over 75, what does that give me? Just give me 3. And then that's my final answer. Okay? Any questions? All right, let's do one more together. Last one you can try on your own. 2 natural log x plus 1/2 natural log x squared plus 1. Natural log is log base what, if I need to put a number there? E. Okay. Do I have any numbers that can move up into the exponent? Got a couple of them, right? A 2 and a 1/2. So I'm going to have natural log of x squared plus, when I have a 1/2 in the exponent, what is that? We talked about this last week. A 1/2 in the exponent is the same as, I thought I heard somebody say it. We're whispering. What is it? Square root. It's the same as a square root. So you will not write a 1/2 power. You will instead put stuff under a square root. Or if it was a 1/3 power, you would make it a cube root. So in this case, it's going to be natural log of the square root. And this is why they put that parentheses there for me. They're telling us all that x squared plus 1 is going to be under that square root, or to the 1/2 power. Okay, so then I look for, do I have any addition or subtraction? Now, I do have addition here, but that doesn't do anything. It's addition between 2 logs. So this is the only addition that's allowing me to condense, okay? And because it's addition, it's going to change into what? Multiplication. So now I'm going to have a single natural log, log base e, and then I'm going to put parentheses here just to like emphasize it. X squared is multiplied by x squared plus 1 under the radical. And then that's our final answer. Okay, you guys try the last one. See what you can do. All right. This one's a little tricky because of the parentheses. Again, it's kind of like an order of operations. We're going to do what's inside the parentheses brackets first. Those 2 logs I can condense together to make them multiplication. And we know how to multiply x plus 1 times x minus 1. We FOIL that. That's where that x squared minus 1 is coming from. Then you can move the 1/2 up into the exponent, which is where we're getting that radical from. Yes?
The number doesn't have to be like directly parallel to
So other way to think about this problem is you could actually distribute that 1/2 into both of them. There's a 1/2 in front of both of them. And then we could move the 1/2 up into each of them, and then you can multiply square roots times each other, and you're going to end up with this. So it is in front of both. It's just been like factored out. Make sense? Okay. Other questions on this one? Okay, so that's condensing multiple logs into ideally a single log. All right, let's look at the opposite now. Okay, so now we have a condensed log and we want to expand it. So this is where our answers are gonna get long. Okay, we're doing the opposite here. So the first thing that we're gonna do, if we can, is bring any of those powers down using our power property. Then, if we have division, it's going to change into subtraction between two logs. And if we have multiplication, I don't like that. You guys know that means multiplication. I hate writing it like that. It's multiplication. It's going to change into addition, okay? Whenever you use a property where it's multiplication or division, when you are separating, make sure each new log you create is that same log base. So if I start out with this first problem like a natural log, every single log I write in that problem is going to be a natural log. That is never going to change. Or if I have a log base 2 in that last one, every single log I write is going to be a log base 2. All right, so the first one, do I have any exponents in that log that we can bring down in front? No, the only thing I have is division. I have a numerator and denominator, and division changes into subtraction. So how I would expand this is I'm going to change it into two natural logs that are subtracted. The numerator goes first, 2x minus 1. The denominator second, x plus 4. The only other thing I see in this problem that potentially could be something that I use is I do have multiplication with this 2 and x here, but that minus 1 is also there, so that's preventing me from doing anything else. If that minus 1 wasn't there, if I just had two things inside the log that were multiplied, I could separate that a little further into addition. But because that minus 1 is there, this is as far as I can go with it. Okay, let's look at the next one. Natural log of the square root of x to the third, y squared, z to the fifth. Okay, so we need to remember that a square root is the same as what power? 1/2, okay? And if I have a 1/2 power, the first thing I want to do is bring that guy down. We're also going to eventually bring the third and the second and the fifth power down, but I can't get to any of those until that square root's gone. So I'm going to bring the 1/2 down, and then I have natural log of all this stuff, x to the third, y squared, z to the fifth. And all of those are multiplied by each other. Okay, and that's the only thing that's happening there. It's one big product. Everything's multiplied. So all of those multiplications are going to turn into what? It's going to change into addition. That 1/2 I brought down is going to apply to everything. So I'm going to put a bracket or parentheses, whatever you want to use, they're equivalent. I'm going to have a natural log of x to the third plus a natural log of y squared plus a natural log of z to the fifth. Now that 5, 2, and 3 are the only powers inside those respective logs. So now I can bring all of those exponents down in front of those logs. The 1/2 again is still just hanging out front. So I'm going to have 3 natural log x plus 2 natural log y plus 5 natural log z. And then an optional step is you could distribute the 1/2 through. I don't think that makes it any more or less expanded, so I'm just going to leave my answer like this. Okay, and then one thing you want to check at the end, make sure you've addressed all of those things. All my powers are brought down. I don't have any more multiplication. I don't have any more division. Okay? All right, see if you guys can do the 2 at the bottom. Give you a couple minutes. All right. Answers. Make sure for that second one, your x minus 1 and your 2x plus 1 are in parentheses. If we don't keep those in parentheses, it means something different. Okay. You can see I'm doing the addition and subtraction at the same time. It's addition or a positive term if it's in the numerator. If it's subtraction or if it's in the denominator, it becomes subtraction. One thing we could talk about is what if there's more than one thing in the denominator? Like, let's pretend on the one that's in blue there was like a W down there, all I would do is put an extra minus log W, okay? Because it's in the denominator, it's subtracted, it's divided. Does that make sense? Okay. What questions do we have expanding our logs? All right. So I just have one more slide for you, and we're all set for today. We'll finish this lesson tomorrow. Okay, so you're going to see some problems in MathXL that give you some information about the log, and they ask you to evaluate. If they're asking you to evaluate, you are only using the given information. You are not solving, you are not plugging things in your calculator, because values will eventually be rounded here. They're whole numbers, but they will be rounded and your answer is going to be wrong if you try to put things in your calculator. You need to only use the given information to complete the problem. So really, as long as the calculations aren't too crazy, these are ones you could even do without any calculator at all. So here I'm given log base 5 of z is 3 and log base 5 of y is 2. And we want to use that information to evaluate the logs. What's not written in the instructions is that you need to expand your logs completely first before you plug anything in. If you plug something in before your log is expanded, your answer is going to be wrong. Okay? So let's look at the first one. I have multiplication inside my log. Multiplication turns into what if I expand it? Addition. Okay, so I can change this to log base 5 of y plus log base 5 of z. And I have no more multiplication, division, or powers to bring down, so I'm expanded completely. Now we use the given information. Log base 5 of y is what? 2. And log base 5 of z is 3, and my answer is 5. Make sense? Okay, so let's do the next one. Log base 5 of y over z. If I expanded that, what would it look like? Okay, and log base 5 of y is equal to? Two minus log base 5 of z is equal to 3. 2 minus 3 is, see how there's really no like evaluating logs happening here? We're just expanding and then plugging in what we know. Make sense? Okay, last 4 years to try. We're going to put these 4 answers on the board, and then we are done with this lesson for today. All right, go ahead. Expand completely, plug your values in, simplify. Yours, you can check those answers on the board. 2 minutes to work on MathXL if you